Thank you everyone for tuning into Coding Talks podcast. I am Vishnu, the host of this podcast. I am an AWS community builder for the past 6 plus years in AI engineering. Um, Initially, I was into the AWS storage community builder program, and from the past 2 years, I moved into the AI engineering when the generative AI and agentic AI capabilities became more popular in software development. I am a lead architect. I work with the different cloud technologies like Azure, AWS, and so on. This episode is focusing on an experience sharing working with the Cloud Code. Cloud Code is a popular agentic AI development tool from Anthropic. I worked with other agentic AI development tools such as Microsoft Copilot, AWS Kiro, Codex, and so on. There are other vendors as well. All of these tools almost work in a kind of a similar fashion. Some have some more capabilities, some are a bit more smooth compared to other vendors. While working with Cloud Code, what I felt is the tool is quite good based on your prompt and context. You will get the desired agentic AI output for development. When it comes to development, you get the output in terms of especially the code development in any language form. It can also fix the bugs. It has integration with the MCP servers, and also if you want to do some repetitive work from Cloud Code in a repetitive fashion, you can create skills and execute it repetitively. You can do vibe coding. Vibe coding is a kind of a on the prompt coding. You can do spec based development. Spec based development is a form by which you can create a plan file or a spec file in advance, and then let Cloud Code implement those spec based instructions. Last year, AWS came up with a kind of an AI assisted software development lifecycle. The spec based is similar to that. You can check out the keynote about the AI SDLC. Basically, it's using a spec for the development, and then iteratively improve on those spec for implementing the features. You can do the same with the Cloud Code as well. Today in this episode, we will be going from start to understand how you can get started with Cloud Code, some of its capabilities, some of the tips and suggestions, and how you can save some of the tokens. So let's start. To give a context about Cloud Code, it's an popular AI agentic AI development tool from Anthropic, and you can create a free version of Cloud Code. With that, you can get some feel about how these models work behind the scene. But for to get an actual development, you need to have some form of a plan in Anthropic, which you can understand by getting into the Anthropic website. I'm not sure about whether any free plans are available because mainly I use an enterprise version. In enterprise versions, there are different multiple plans, starting with the max plan, and then goes up to the unlimited plans. Comparing to the other vendors like the Copilot or the Codex, you need to pay a certain license fee also to Cloud Code per user. especially for enterprises. So actual cost of Cloud Code includes the license cost. uh, I believe it is around $20 or something. So for each user there should be a license cost plus the tokens for the cost for the tokens. That the cost for the tokens will be included as a kind of a plans, like you can opt for unlimited plans. uh, it is similar to what we call as pay as you go plan. Like if you consume around $50, you have to pay that. Then there is a plan called max plan 100, where you can consume up to 5 million tokens. Then there is a $200 plan where you can consume up to 11 million tokens. Please check the Anthropic website for the accurate detail. This is an approximation that I am explaining here. Then there is an unlimited max plan also available for enterprises. Nowadays, as of this recording of this podcast, which is happening in August 2026, almost all the AI vendors, AI agentic AI vendors, including Cloud Code, Copilot, Codex, everyone has moved to a consumption-based approach. Previously, this was something like a kind of a unlimited model, where you can use as many tokens as you like by paying a fixed amount per month. But now the situation has changed, and almost all vendors that I aware of, including the Cloud Code, they are moved into a consumption model. So consumption model is that there is no unlimited plan. You have to pay based on your usage. So this led to certain challenges as well, because previously everyone can use in an unlimited fashion. They can take advantage of AI. So agentic AI becoming a kind of a popular term among the developers, because with a minimal understanding and with some context, they can easily develop using with the help of agentic AI tool. But when these models move to a consumption model, what happening now is the developer or the person who actually prompt this needs to aware about how that prompt should work, how efficiently he can provide the prompt so that he can save the tokens. Otherwise, everything will have an associated cost underneath. So if you are not careful and if you provide a prompt to go through the entire code base, then it will consume a lot of tokens. So the prompt has to be specific to save the tokens. That is one of the challenge that is happening nowadays when these models moves into the consumption plan. Now coming to the Cloud Code, once you start getting into the Cloud Code, you can interact with the Cloud Code in a multiple ways. One way to interact with the Cloud Code is to integrate Cloud Code from within your favorite editor. For .NET development, I am mainly working on .NET development. For .NET development, developers usually rely on VS Code or Visual Studio Professional. I am not aware of any official Cloud Code extension available for Visual Studio Professional. There is an extension available for VS Code. Usually, whenever we want to work within a .NET solution, we open the Visual Studio Professional, and then parallelly open a VS Code as well, so that we can prompt to the cloud and we can get feedback, or the actual running of that we can do that in the Visual Studio. Since there is no official the Cloud Code extensions available within the Visual Studio Professional, this is a kind of a way which I usually rely upon. There is one another way also, like familiar with the command line prompt, you can connect with the um, Cloud Code using the CLI tool as well. And also, Cloud Code also provides a Windows graphical user interface, which is Cloud Code tool, which you can install as a standalone application, and then you can do the prompt as well. But to me, I feel personally, I feel VS Code as an efficient interactive tool, because just by installing a Cloud Code extension, you can authenticate with the Cloud Code, and then you can do the prompting. You will get a feel of what all files are there by exploring within the VS Code. And for front end development, this really helps as well. So rarely I use the VS Code, the Cloud Code related standalone graphical user interface. It is quite good. The standalone Cloud Code interface tool have three different sections. One is the chat section, where you can provide on inline prompting, on the demand prompting. So there is a project section also, where you can associate a project and then can iteratively work with the cloud. This is particularly useful when you want to isolate your context to a specific project. This is also helpful when you want to generate artifacts related to that project and want to hand over that project to a different team, like a specific architect team or something. This project based approach should be useful in that case. Then the co-work option is also there. I haven't tried that. That's a different way by which you can integrate the workflows and all. For co-work to work efficiently, you need some parallel processing as well. That is my understanding with Cloud Code. Even without these standalone Cloud Code tools, by just installing the VS Code extension for Cloud Code, you can start working on the Cloud Code. So first of all, create an account with the Cloud Code and then authenticate it, and you can start working on that. Now, if you have a single repo, open that single repo with the VS Code Explorer, and then you can prompt it to the VS Code. The benefit of this approach is that the Cloud Code will get a complete understanding about the context of your repo. If you are working with multiple repos, one approach that I usually follow is to create a project folder, and then underneath that I will clone all the multiple repositories and then open the VS Code Explorer in the root folder. Root folder means the project folder. This has some benefit because if you want to work with multiple repos at the same time, Cloud Code can work parallelly, accessing each of these reports at the same time. To give a context of how this works, let's say an example where you want to develop some feature related to the front end and the back end. One approach is like you can work one by one. First, you can give a prompt and develop the API, and that is the back end, and then you can work on the front end to work on that part. But the easiest approach is like, instead of that, you can create a specific prompt with a specific instructions for front end and back end changes. You can specify which repo you are using, and if you clone that every repos under a single project folder, the VS Code Cloud will get a full understanding about that specific repos. So from your prompt, it can work parallelly at the same time. So that means you can provide some specific prompting uh, at the same time for both front end and back end repos, and it can work on that feature. This is the starting point of parallel development with Cloud Code. Behind the scene, how this works is Cloud Code has the uh, integrated CLI tool, which is quite powerful. Uh, it can uh, it can create multiple CLI instances based on your prompts. So if you want to work on 10 repos at the same time, Cloud can work in that similar fashion. It will be based on the prompt. This is useful in some cases. For example, if you want to add some specific key or a key vault related changes to say n number of repos, with a single prompt you can work parallelly on multiple repos. You just needs to provide a context of what all repos that you need to work with, and then instruct what specific task you want to achieve, and then provide that prompt to the Cloud Code within the VS Code, and then it can parallelly create multiple instances of the CLI tool that work with multiple repos. Once it works with multiple repos, the Cloud Code has an integrated uh, loop mechanism by which it iteratively go through these instructions again and again until the desired output is reached, and then it will improvise that and then finally provide you the result. Once it provides the result, you can validate the changes, and based on the validation, either you can stop that development at that stage, you can commit it. Commit also can be done with the help of this Cloud Code, because it's quite powerful. Like it has multiple the CLI tools, so it can interact with the JIT and even can commit the code. It can pull the request. It can create pull request. It can pull the latest changes. It can do merge, rebase, and everything from within the chat interface itself. So this means that from within the VS Code chat interface, you can do almost everything with the help of Cloud Code. This is quite powerful. One of the drawback of this approach is that for everything there will be an associated token usage. For some trivial things like the commits, the JIT commits and all, there won't be much usage of tokens. But you have to be a bit cautious about that. You have to constantly observe the usage of Cloud Code. That is one approach I following. There are multiple approaches as well. Some developers using some tools, they calculate how much token a specific activity will consume, and then based on that they will improvise the prompt and narrow down the prompt to a specific repos, and then they work on that. Or an alternative way by which usually I follow is like there is a specific page within the settings of the Cloud Code. If you open that, you can see how much tokens remaining, and that way you can keep an eye on the usage. Sometimes when you provide prompt, if you feel that there are too much token consumption going on, you can stop that, and then you can proceed it accordingly. There are some tips also I can suggest in this episode after some time, so that also can help. So all these opinions are purely based on my experience. Sometimes there will be some changes or some deviations from that, which you can learn from your experience. So feel free to consider whatever suggestions or and try it and experience it from your own way of coding. Now, yes, so the token consumption is what we were discussing last. Now let's look at some of the models that are available within the Cloud Code. and other tools like Copilot, Kiro, or something, you can see a lot of other vendor models as well. But within the cloud code, uh, normally I could see only cloud code specific models because this is specific. This tool is specific to Anthropic, who develop these models. So usually I didn't saw any other models like GPT models or Microsoft specific models within the cloud code. But I could see a lot of cloud code specific Anthropic models, starting from Haiku, which is the basic model. Then comes the Sonnet, then comes the Opus model, then the Fable model as well. This also depends on the regions. This is what these four models are the general models that you can find it. Anthropic constantly researching on newer models, and at the time of uh, whenever you are listening this podcast, there might be more models, or some of the models that I am discussing here might have changed a lot. Uh, that's a constantly evolving one. But as a agentic AI developer of cloud code, you have to be cautious with the models that you use. Usually, higher end models like Opus and models, they are quite slow, and also they consume a lot of tokens. But when it comes to the capability and intelligence, they are quite high in those things. For most of the code development activities, you can rely on the Sonnet model. Sonnet 5 model is the latest model as of the time of this podcast recording in August 2026. Uh, Below Sonnet, there is a model called a Haiku, which is the basic model. And Haiku is also quite powerful, and it can do most of the tasks. And you should consider Haiku as the first uh, model to try with whenever you start working on a development. And if you feel that Haiku struggles in sometimes, especially when it fails to understand the intent of you, or you are not getting any desired output with Haiku, then you can switch over to a different model like a Sonnet. So before switching over, if you are working in the same session, uh, make sure to write uh, all the important findings or learnings that you arrived or you derived during that point of time to an MD file, and then you can work on a different model. This is a best practice also, because what happens is if you constantly write the important things into an empty file, um, the cloud can restart that specific context a bit later using that same MD file. But if you clear all those contexts without writing that to an empty file, then it will be a challenge for you to come back to that context. You can come back to that context, provided if you write that to a memory as well. But the one of the best practice is that you can write that to an MD file. You can instruct the cloud to do that. So after certain prompting, you can see the context window of that gets full. So there will be an indicator, and sometimes cloud instruct you that the context is getting full and going to compact. Before compacting that, you can instruct the cloud to save this either to a global memory, or you can write that to a MD file. The benefit of having that to an MD file is that you have a uh, good documentation related to your work, and also you can restart that work later from a different context as well. Just with an instruction, it can write it. But for all of these things, keep in mind that these all consumes some level of tokens for sure. But again, writing it to an MD file and truncating it. Truncating means compacting it can save a lot of tokens, especially if you let's say if you are working on a front end and back end application from a single chat window context within the VS Code. After a certain point of time, you will be iteratively prompting like I want these changes, I want that changes, and so on. And then after some time, these all instructions repeatedly going forward from back to your system to cloud and come back, these are actually context actually. So these are some of these details are unnecessary, and compacting can help a lot in that case to free up a lot of tokens. But by compacting that, you will lose a lot of details. To avoid losing specific details or productive details that you derived until that point of time, it should be good to write that to a memory or MD file, and then you can compact it. This can save a lot of tokens. So coming to the token saving part, one of the best tip is to start with a lower model like a haiku. Sometimes that should be sufficient for most of your task. If it doesn't work, then go to the higher end model. Um, Later in this episode, we will be talking about the spec based development practices, and during that time, uh, during the plan phase, you can rely on higher end models like Opus, and then for implementation you can do with a kind of a lower end models like a Sonnet and so on. That should be a good approach. But even what I felt with the Sonnet is even Sonnet also consumes a lot of tokens, and Haiku is much cheaper. You can use the double tokens with lesser cost using Haiku. Um, to me, honestly, Haiku is a kind of a underrated model, because most of the time we straight away go to Sonnet, feeling that it can do a lot of things, but Haiku is quite powerful, and sometimes we assume that our task is quite heavy, and we need a Sonnet for that, but it's a kind of an over usage, I would say. So we can start with the haiku instead, and then move to the higher end models. And sometimes I have seen teams using opus model for most of the trivial task. That is also a wrong practice, because actually opus is usually suitable for complex cases which needs a lot of thinking, and the model is quite slow as well. More worse is its cost associated with the opus model. It costs a lot of for the tokens. So unless it's absolutely necessary, go ahead with the haiku and then move to sonnet. And then if both of these doesn't work, then go for the higher model. The recent one have fable and all, it's very costly. There are some specific models that are available in some specific regions, that for specific security purposes and all, that also it's bit costly, like I think Anthos or something like that. I haven't used that, but that's also quite costly, and those were available only for certain regulated industry users. Okay, now all of the things that we discussed here up to now, it is based kind of a vibe coding based prompting. Vibe coding means simply you prompt on the demand when you want to achieve something. This is the way usually developers work previously. Whenever they want to do something, they go through the requirement either from the Jira or from some story backlog. They understand it, then they create a prompt, and then they do the vibe coding. Vibe coding means on the demand coding, on the fly coding, which you can help with that with any tool, including uh, Cloud. The the vibe coding approach works good, but what happens is it lacks a centralized control. The reason for this is the way by which each user prompt or each developer prompt can vary. It is subjective to that user. So maybe developer A will be prompting in a specific way, developer B will be prompting in some other way, and each developer will be doing in their own context. So this means that there is no central control over how the development AI works, development AI moves forward. This will be a challenge when it comes to the final review or the code merging. Even if we ask the developer, they were not aware of what they were doing because they were usually doing a vibe coding. And what happens with this vibe coding is they frequently provide a lot of prompting. Sometimes even they fail to write all these to an empty file with the help of Claude. And after that, they will clear the sessions. The in VS Code usually those sessions will be available all the I think up to 20 or 30 last used sessions were available so that you can go and rewind it. But sometimes what happens is sometimes these also gets truncated and lot of the context gets eliminated automatically to save the token. So this means that even the developer is not aware of what he or she done a few minutes back or a few days back. This will be a problem when it comes to review or even for that developer when they want to work on later on a bug which is associated with a specific feature. They need to recollect all what they have done. Since this is being done by AI, they get no idea of how to what they have done during that. So again, what they do is like they will ask the cloud code like what all we have implemented. Then it will go deep into the code base and tries to understand what all have done based on the Git logs and all. It can come up with some findings which most of the cases should be correct, but the problem with this is that it consumes a lot of tokens. So every time you instruct cloud to do these things, first of all you need to wait a lot of time, secondly it consumes a lot of token, and third in some cases what happens is if you were not prompting in a proper way and cloud does something and later it comes with a different inferred results like how it was already implemented, then you will reach a state where you will get no idea on how to fix this and so on. So rather than going in a vibe coding approach, the modern approach is like a kind of a spec based approach. In spec based approach, uh, what usually the software development team do is first they identify the stories that needs to be completed in a specific sprint, just the usual process, and they document this in some form in Jira or some other tools, whatever tools. So they write specific acceptance criteria in Gherkin format, in clear detailed steps, what each task should be doing, what is the acceptance criteria. If you want if you want to include some screenshots or some specific UA related Figma, you can add all those to the stories. Figma, you can keep the designs in the Figma. Figma is a different tool, and all the stories, the descriptions, the acceptance criteria, and other details relevant to the story should be there in some form of a DevOps or a tracking tool like Jira or Trello or whatever, or Azure DevOps, GitLabs, or whatever way you prefer. You can keep it there. So once these stories are finalized, written in a proper way with a clear guidelines, acceptance criteria, and the screenshots, if it is a UI related screenshots of how that UI should be like, or a mock-up of how that UI should be like, then the cloud can check into those specific Jira backlogs and create specs for you. So specs can be created from a single story, or if you have a lot of stories that you need to cover in a specific sprint, you can create epic, create an epic, and then you can you can attach a lot of stories underneath that, user stories underneath that epic. And once you have this kind of a story set up in place with a clear defined guidelines and acceptance criterias, then you can instruct the cloud code from within your Visual Studio Code to go and find the specific epic and its associated stories, and then create a spec for you. So this process is called as the spec based process. And for doing this, you can use a higher end model like Opus, because this is an on time activity. You can do this with the help of Opus. If you are if you are fine with the usage, again keep an eye on the usage while doing this. If you have a lot of stories, and if your instructions are not clear in the stories, this have a disadvantage as well, this approach, especially when you're using the Opus model, because it will consume a lot of tokens. So make sure first of all the stories were written in a clear and understandable format, so that you can understand it better. Avoid the confusions regarding the different stories. Have a have a discussion about all the stories with the different team members, and then have all these clear instructions in place as the preliminary requirement before starting spec based development. Then let the instruct the cloud to go through the epic and find all the stories and create spec. So spec you can create in two different approaches. One is like on you can create that in a kind of a HTML format, uh, or you can create that in a kind of an MD file format. So MD file format is a plain text. It can save a lot of tokens. HTML on the other hand is quite verbose with a lot of tags and all that will consume a lot of tokens, um, and not a preferred approach in most of the cases. But there's one advantage for the HTML based spec, because uh, it gives you a lot of readability. So if you instruct, you can try this. You can instruct the cloud code to create a HTML based spec, and you can find it um, uh, how uh, well a readable spec it creates, like with the tables and all. The side disadvantage is that when each time when you consume this, there will be some additional token usages. Cloud has specific ability to parse specific regions of the spec. So if you have around 5 or 10 user stories, and if you have that associated in Jira, each one of these stories have associated Jira ID, and each one will be in a specific area in that HTML spec. So that way also some level of optimizations cloud will be doing behind the scene to specifically find, fetch and parse that specific area. But again, still the MD file based approach, .md file based plain text approach will be more efficient in terms of token consumption. And since it has only the textual content, right? So that will be more efficient in terms of token consumption, but for readable HTML. Now once you have this in place, then you can instruct the cloud to go and implement that. For implementation you can use the Sonnet model, or maybe you can start trying with the Haiku model as well. Now while creating the spec, this API like a on step, on shot prompting. But in most of the cases, Cloud can come up with a lot of suggestions, like based on the different stories. For example, if you have a main story and an associated story, uh, and in the if you specified something in the main story that doesn't matches with the associated story, then Cloud can flag it and can help you to correct it. So this way, a lot of initial iterations you need to do while creating the spec, and spec creation will consume a lot of time. This is why recently, if you look into the Swami's keynote in the AWS, so he mentioned that initially during this spec-based or SDLC-based approach, there would be a slowdown initially. Teams have to adapt to this. They have to go through the spec and make the requirements clear. So they cannot straight away start working on the task. Instead, they have to create the spec in advance. So this should happen through multiple discussions, multiple iterations. And once that spec is in place, the benefit is that you will get a good documented implementation spec with all the details, so that this can be used by any developer, or even even the main person can implement this. Uh, this way, development activity can be streamlined. So the main benefit of this approach, spec-based approach, is that once the spec is created, it acts as a documentation, and there is a control within there, so that the implementation can be anchored in that specific way. Otherwise, what will happen is each person can prompt in their own way based on their own understanding, and then uh, goes into the implementation in different ways. With spec, you will have a tight anchoring and a tight control over how you want the application, how you want the development to happen. And one of the other benefit of the this spec is that, let's say after a few days there is a change in one of the requirement that has to be corrected in other stories as well. Might be there will be a single requirement change in one of the stories that will have an impact on other stories as well. So Cloud can easily identify that and implement all these things very easily, provided if you have a spec in place. So this is the benefit of having spec based development. And if you gone through the multiple blogs or the recordings that shared by AWS and Azure in the recent years, you can find that spec-based development is required for complex software development activities. Vibe coding can help to some extent, but it's not effective for complex software development cycle. Hope this is clear. And now we will be discussing on another important topic, which is called the memory. Cloud provides memory for enterprise plans. This means that while you're working on cloud, you can instruct the cloud to keep some specific information or best practices in memory. Memory can be in two different ways. One is a kind of a local memory, where you can keep in your local system globally. You can simply instruct the cloud that if you want to remember cloud to remember something, say for example, if you have a database, a DB specific repo in your project, and if you want to create the scripts file in a specific format, you can instruct the cloud and you can keep that in memory. So the best practice is that you can keep this memory or these instructions as a standing order instructions or memory within the repo itself, so that everyone can take advantage of. But if you want to have your own specific, that is the personal choices sometimes, like say for example, I usually um, uh, commit after validating everything, even in locally. So but the default, if you look into the cloud code, whenever you provide it to do something, it can fetch, it can create a new branch from the repo using the CLI tool, and it can pull the latest changes. It can work on that feature directly, and it will immediately commit as well. If you have some specific suggestions, like, okay, let's say not commit immediately after making Cloud make the changes, I need to validate it, you can instruct the Cloud that, and let the Cloud save that in a global memory specific to you, to your local system, so that what happens is, whenever next time when you make some changes, Cloud won't commit immediately. It will wait for the wait for your explicit instruction. And another point is, um, during the commit, if you want to have the commit in a specific format, you can instruct the Cloud to do that. If you want this to available across the team, then the best way is to write this as a readme file, in readme file within the repo, and so that others can also benefit from this. Cloud will by default goes to the that readme file, that MD file, and then it will do the instructions. So that means that if you commit those to the repo, when other let's say a new developer who joined, who is not aware of these things, they can also understand, they can also by default get this benefit from this readme file. So Cloud will commit in a specific way even for that user, a new user, even if they don't provide any instructions like that, to commit in a specific format. This way, the memory, global memory, and this kind of a standing instructions has its own benefits, and please take advantage of that. Uh, One main important thing to keep in mind that uh, occasionally we should review these README files or the memories, and instruct Cloud to remove uh, practices which are no longer required, or completed stories, details from the memory, because it can free the Cloud a lot of unnecessary context, and it can save a lot of tokens as well. Because if you keep a lot of instructions like this, the steering instructions within the file, in a lengthy way, then it can have an impact on the tokens and then the associated cost. So keep it limited, keep it minimal, keeping only the important points there. Okay, that covers the memory and the steering instructions, the README file as well. Next, we are going to discuss about a capability of these AI tools, which is called the skills. If you want to repeatedly execute certain things, you can add those as a skill. Skill is basically a template of instructions, and then you can store that within the repo or within the specific folder. The benefit of this is that once this is in place, next time when you want to do certain things, then Cloud will automatically do that for you. Cloud will automatically identify that specific skills and do that for you. uh, Behind the scenes, Cloud has some inbuilt skills, so that is why whenever you provide some instructions to fetch something from Git, or to push something to the Git commits or something, is it is actually relying on those inbuilt skills that are provided by Anthropic and then working for you. Similar way, you also create some specific skills. So let's take an example. If you want to identify the number of commits that you made during a specific point of time, you can create a specific skill for that, and then you can store that skill in some repo. And whenever you want to get a metrics of that, you can instruct Cloud. Cloud will call these skills means these associated instructions, and it will do that for you. So this is useful in scenarios where you want to repeatedly execute something. Skills are also a kind of a prompt. So whenever you use skills, that also gets counted against the tokens. So everything you are adding to the skills, actually it counts to the tokens. And also please make sure that the skills will be run on behalf of the user. But if the skills were not written in a proper way, and if it has some problematic instructions, then um, it will have an impact, especially if you commit those skills to the repo. Let's say if it has some instructions in a different way, so that it misunderstood something and delete something, then that can impact the other user as well. So everything will be executed on behalf of that user based on the permissions and all. But still, if there is an uh, unwanted instructions there, then it will have an impact. So skills needs to be written in a proper way. Always make sure that whether we should create a skill or not, because for all the tasks usually there is a pattern that we could see nowadays, that for most of the things that we can rely on the inbuilt skills, rather than relying on that, the developers are going to create a new skills just for that, so that they can use it. Skills are useful, but always try to see whether there is already a skill or an existing capability there within the cloud, so that we can rely on that rather than going for no new one. And another important things is to uh, create some instructions, like if you want to cloud to behave in a specific way while outputting the results. Uh, Sometimes I feel like cloud is actually explaining in a lengthy way, which is usually not at all required. So in that case, you can either provide a on the demand prompting, like please show the results in a minimal one or two paragraphs, or you can keep a steering file within as a readme file within there, so that it affects every developers, and they will also see a limited. So this can actually save a lot of tokens. For input and output, there will be a token associated token consumption. So if you can keep it minimal, that will be good. And sometimes when you feel that whenever you are providing prompt to a haiku model or a base model, if it is not working as expected, or if it is getting a lot of context getting filled immediately, then take a pause and write all these informations, instruct the cloud to write all this to an empty file, or an associated file somewhere in global memory or some other location, and then continue it, then come back to the corresponding context and then proceed it. And always try to create a separate context for different things, rather than using a single context and clearing it, because whenever you use a single context and clearing that, the problem happens is whenever you want to come later to that work, to identify to fix some bugs related to that feature or something, then it will be challenging for you to understand, or to let the cloud know that what you have done previously. So rather than cloud is actually stateless, these models are stateless. So if you ask something at a different point of time, it will give a different results. This is one of the characteristics of these AI systems. So to take advantage of that, you can either use a README file, or an empty file, not README, empty file, or you can use something like a global memory in place. You can commit those to the repo to take advantage for other users, to let the other users get advantage from this. But if it's something specific that you want for your personal development or your specific way of development, then keep it globally within the local system. That should be a preferred approach. Okay, with that, I think we have covered everything related to Cloud Code for you to get started. Uh, to um, to summarize, for .NET development, and other forms of development, VS Code has an extension for Cloud Code, and you can use that, or you can use a combination of the Cloud Code for Windows, which is a UI tool provided by Cloud Code, which you can install on the Windows system and can work on that. Then we haven't covered the different other areas like the co-working and all with cloud. Anthropic has good number of courses there, so that you can work on that and you can go through that and learn about it. And for those who are new to cloud code development, please go to Anthropic website, uh, create an account and start playing with the cloud code. And there are a number of courses, free courses available within the cloud code. Anthropic is also providing certifications, uh, and certifications has an associated cost associated with that. Certifications starts with the associate, foundational associate certificate, which is quite helpful for getting a general awareness about the cloud code and to get started with that. Then comes the architect level certification. Architect certification deals with developing agentic AI workflows and systems using cloud code. Then there is a developer associate foundational certificate as well, certification as well, which is related to using APIs, cloud related APIs. Uh, so for a good start, associate certification should be good to start. The other certification are a little bit more tougher than the associate level, because it goes into that specific streams like architect or associate. Even if you don't want to write the certification, still you can go through the courses there in the Anthropic website, create an account there, and you can go through the courses, and you can learn about it. Free courses are available. Most of the courses are free actually, and you can go through that. Then yep, I think we have covered almost all, and let me think about anything else to cover up here. Um, yes, we are good to wind up now. These are an overview that I mentioned here. Um, Please go through the documentation in detail and learn more about use cloud code for agentic AI based development. One more final point I want to mention before winding up. All the things that we discussed right now are from a point of view of agentic AI development within either the VS Code or some other tool. Cloud also provides an API, a Cloud Code API. And this means that you can integrate the Cloud Code from the DevOps pipeline as well. This is useful when you want to do some scanning or auditing of the code changes and provide some review comments uh, from the cloud itself. This is a best practice which most of the teams can rely upon. They can create a kind of an instructions within the repo, and they can use the cloud code API to trigger that from within the pipeline. So what happens then is that once you merge those commits, immediately cloud will start review preferably using the higher end model like Opus model, through the specific set of code bases, and then it can flag the review comments. Then you can go through that review comments, and then you can fix those review comments. So this will be a good practice. It acts like a kind of a review on behalf of Cloud Code itself. This way you can review locally as well. There is a way by which you can use Cloud to review that changes and fix it locally before committing those changes. Everything for all these, actually you need to keep a balance, because if you have limited tokens, then if you go on and implementing all this all the suggestions that are providing by Cloud, then you will be consuming a lot of tokens. But keep a balance rather, and focus on the main things that you want to that you want for the feature development, and the other enhancements are maybe you can add to a backlog and can consider later as well. Before winding, yes, one more thing I forgot to mention here is the MCP server integration. While we were discussing about the Cloud Code pulling the epics and the related stories, uh, uh, the important thing to aware here is that to make this happen from within the Cloud Code, you need to first connect the Cloud Code to Jira using an MCP connector. Most of the tools like Slack, Jira, Trello, and everyone have an associated MCP connectors. So MCP connectors are a kind of a symbol. You can think of it like a standard API interfaces. It's not API, but it's a kind of a protocol developed by Anthropic. And using this MCP servers, your cloud will get more context about the different other tools. That means that once you create an account in Cloud Code, you can install the Cloud Code extension in VS Code, and after that you install the Cloud Code for Windows application, then open the connectors tab, and then identify the connectors. So most of the time, if you are part of an enterprise admin provides a list of associated MCP servers that you can connect. So these MCP servers are endpoints or interfaces that is within that organization. So it's a kind of a restricted environment. So you can connect to the Jira or whatever tool you want, and the benefit is that you can instruct the cloud something like from within the VS Code, like hey, please check the Jira ID, and then fetch the details and start creating spec or implementations and so on. So this way you can directly interact. Now the disadvantage of this integration is the consumption of tokens. So whenever you instruct something to fetch from Jira, or sometimes the model thing like to clarify this prompt, I need to go to the MCP server. So it has some intelligence associated with that. It will go to the MCP server and fetch the details. MCP server is certainly useful. One example is if there is a requirement change or something, or during the spec creation time, you need a MCP server integration. But always go picking the details from MCP server, it will consume a lot of tokens. So you have to keep a balance in that way. MCP server also provides the different ways by which you can post comments directly to the user and so on. Everything will be done on behalf of the user. So if you are instructing Cloud Code to post some comments to a Jira to a specific user, Actually, that user can see it's posted by you. So because Cloud Code is using this CLI tool behind the scene and posting this, this means that by taking advantage of the parallel ability, Cloud Code can uh, maybe it can post multiple comments to multiple Jira tickets at the same time, or even it can change the status of a Jira ticket and so on. Everything these will definitely incur some token usage, but it will be minimal. Like for these activities it will be minimal token usage only, because what happens behind the scene is whenever you provide a prompt, the associate underneath LLM, whether it is a Sonnet or Haiku, will understand this requirement. Then it will just initiate that CLI tool and call that particular tool. This is how it works. So it consumes only a minimal token. Similarly, there are different connectors available. You can explore all those different connectors. If you want to post something to Slack, you can do that. If you want to send some email from email, you can do that. Email in the sense some occasional cases, or if you want to fetch something from email, you can do that. Uh, but for other cases of email, like to send email and all, we cannot rely on this one. For that, some other third-party integrations like MailJet or SendGrid should be fine in those cases. And then MCP servers, a lot MCP server as well. You can create your custom MCP server as well. This will be quite useful for, let's say, if you have a MongoDB associated with your project, and if you want to have a MongoDB MCP tool that specifically want to log into a specific, let's say, an on-premise MongoDB, and then you want to connect and fetch details from there, you can do that with the help of MCP tool. Cloud Code is intelligent. So if you don't have an MCP server, if you instruct Cloud uh, and provide some storage connection strings or something, then it can connect to that associated MongoDB and fetch the details, provided if you have permissions to do that. Everything will be done from on behalf of your machine. So if you are running in an administrator mode, you will get the full instructions. Otherwise, cloud uh, cloud cannot do on behalf uh, on other than the user which it is logged in. So you need to, if you run the cloud code in administrator mode, then it will have more elevated privileges to do certain things. Okay, that's let's wind up. Thanks everyone for tuning into Coding Talks podcast. We will come up with a different episode later. Thank you.